This means that we can dissolve 57 grams of salt in our 150 grams of water. Now we have to figure out, interpret that. Does that mean that our solution is unsaturated, saturated, or supersaturated?
Unsaturated.
Unsaturated, why?
Yes, less than 57.
Right. We determined we can dissolve 57, but we only dissolved 45. So we haven't hit that maximum yet. So it is unsaturated. If we dissolved 57, then it would match. And so then it would be saturated. If this said that we had dissolved to 60, then we're over the maximum, and so it must be supersaturated. Okay? The other way that I see people that like to do this is just look at the ratio between the solute and the solid. And so they would look and say the rule is 38 per 100, which is 0.38. They would then do the same calculation with their solution, which is 45 divided by 150. What does that come out to be? Zero. Thank you. 0.3. And so the higher this number means the more salt you have. The salt is on top. As the amount of salt goes up, this ratio is going to go up. And so that is the maximum ratio we can have. The ratio that we actually have is lower than that. And so it's unsaturated. If the ratios were the same, it'd be saturated. If this one was higher than that, it'd be supersaturated. So out of curiosity, no right or wrong answer, how many people prefer the first way we did? How many people prefer the second way we did? See, there's always some. It's something about how the brain works. There's no right or way. If you get the right answer, you get the right answer. I think this is a good time to take a break. Let's start back at 25 after on that clock, so it's about 12 minutes.
Which I can't.
No, yeah, but I'm switching it. Can we do like,
Okay.
yeah, can we do like,
Okay, that
closer to the date? Yeah, you guys can do it. If we do closer to the date, Monday, which is before the exam. Or Sunday. Or Sunday will be good for you.
Sunday I'm very busy. Sunday I'm very busy, and Sunday's the worst day because then by a lot. Like the buses run every 2 hours.
Yeah. Well, no, that's something else. A little better if we could do like
Then,
closer to the exam.
What about Saturday?
Saturday where? Here?
What do you say? So I stay on
No,
top.
it doesn't matter where.
Stay on top.
Like Williston Road.
There's a coffee shop where I live. There's another prostitute. Journey Library.
Do you know when you register for summer and fall? Is it?
You can do it right now.
Not yet.
No, the classes you can see now, you can't register.
Oh, really? I don't need to sign up for anything anymore, but I remember you could apply. You could get into classes like really early, but you just have to. You can't let the deadline hit you.
It seems like I looked it up and it was like April or something, which seemed oddly late to me. I was like, I didn't trust it. Like, it's right before the semester starts, like a couple weeks before the semester starts. Is it really like that?
For summer?
Yeah.
Yeah, that's how. But you can also sign up for fall right away.
Yeah.
But you have to do it quickly because there's gonna be like a drop off time, and you're gonna have to wait again, like at the end of summer.
Yeah, last year they did it super weird. They opened up both of them at the same time.
Yeah, they do that.
So it was like really difficult to get into classes.
Yeah, the best professors. I know. You talking about shadows? I think everybody would.
Oh, you're right.
There's other ways, but this is the easiest way.
I should be able to do it. Yeah.
I don't know.
I don't know
Some
if
kind
I
of
can
club.
tell Saturday, Saturday,
Maybe Saturday.
Saturday afternoon.
Oh.
Like one.
I don't know. I think I'm not sure.
It looks more like a bat than anything really.
Probably like 12 months. Something like that.
But where you like another year.
I don't know.
If not,
I've seen it before. You gotta have like certain openings too for the
because I
guys.
only have another project to do for your class.
Have you seen those human figure ones? The human figures? They have like theaters. I mean, theater shows about.
With a little
Like,
knife
like,
thing.
no, it's like really like bodies and things shaped together.
Oh, yeah. I remember seeing one.
Those are crazy.
They're all in warp suits. Warp suits? That's it. You know what I'm trying to, yeah, is that it? Okay, that's all you can say.
I don't know that movie.
Oh, it's a series. YouTube series.
So,
No. Oh, isn't it? Yeah. Go on and type it in. It's you have to do it for free. Nobody does. You're done. I'm sure it can all be. Wait, I have to watch that. I don't watch my car. I'm like we're talking about the same stuff. It's not scary, it's funny. The clown was scary.
you guys love skating.
Huh? Dude, I can
You guys like blessing them and stuff. Nah, I'm not about that. I'm not about that. Okay, so we got the design. So Sunday, Monday? I mean Saturday?
I told you what happened, right?
Like before noon, after noon?
It was like a convention group.
Oh.
Yeah, I was talking to them because, you know, they were telling us things that we don't. They said, well, if there's something that you come up with.
You know, our,
So they had all the force and
you know, our church. So
after I did, I was shocked.
maybe we get some Starbucks there, there's Panera, places like that. Where I live,
Honestly, I wasn't sure.
they rent coffee shop rents the apartment.
After I just looked at this stuff.
It's a Barney, Barney's coffee shop. But you know, about the plaza there's Panera, like 2 or 3 Starbucks. There's 2. Yeah, so she's driving now. Tomorrow she can't do tomorrow. So if we can also,
Closer to like our exam.
we can still meet up tomorrow. But I could also meet on Saturday. She was gonna meet on Saturday around noon. So we're thinking about like a coffee shop.
I'll say
In the library over
Or
there.
Panera.
It is, that's what I'm thinking. I think the
There's no way
library-
I'll get a meet here on the weekend.
How far are you
Did you
from?
Like,
what is like?
probably not even 10 minutes rush on car.
You're so cool.
Where's Butterflies on Archer Road?
Yep.
Okay, good. I'll pick you up.
Stay at the, no, you don't live there anymore.
Where?
No, you say you live in Havana.
I used to live across. I don't know. BMW 7.
Is that upgraded or?
It's crazy. I'm from the
I thought it was
Yeah.
Citric Star Wars.
I haven't had any bad experiences.
That's what I just
Serious? I've had so many bad experiences.
Like the roads and stuff?
Yeah. And like my roommate's car got broken
I was,
into last. Like,
I know, I thought it
Are
was.
you serious? I'm trying to figure out why your face looks so familiar. I've probably seen it in the classrooms.
what do you know?
Yeah.
You don't know anybody?
I don't know. I couldn't figure out that.
Just me and my friends, and we all came up from Miami together, so.
Maybe I know your friend.
No, it's definitely in the floor.
It's not worth it. So that's
I'm so thankful I don't have to live with that kind of life. I live with my family, so.
I just have the best FaceTime in the world.
I was about to ask you, how is she? Do I see her close now?
Well,
But you
she's
haven't
like,
found it out now, I
my
don't-
dad got there, like, she wasn't talking or anything, we were talking to her, like, she was like she was unresponsive, like, her eyes were closed and everything. But, my dad got there, like, an hour ago, they just FaceTimed me.
This is in the DR?
No, right here, well, not here in Gainesville, but in Maine. My dad flew in from New York, because that's his mom.
Yeah.
And, my sister-in-law FaceTimed me, and, like, my dad was talking to her, she was replying. Like, what do you, like, she wasn't talking or anything, and the minute my dad got there, she started talking, but not, like, talking, but.
Right.
Verbalizing.
Yeah.
You don't need
Yeah.
sleep, that's a.
How old is she?
94.
Yeah, that's your grandmother.
I mean, it's good.
My grandma.
That's amazing. I know how to do my grandma. She's my heart.
Oh my God, did you understand? Like, today has been a little better for me because, like, she's been, like, you know, progressing. Like, she's not getting worse, but she's not getting, like super better. But, you know, she's getting there slowly. But, dude, for, like, the past 3 days, I've been, like, nonstop crying. Just nonstop. But, I mean, she's 94. She's lived her whole life.
So, one of my great grandparents is my great grandparents.
Like, this is the video I got. Like when it first happened, like when they first put her in the hospital. Which one?
Was she at home or a nursery?
She's at my family's nursing home. Because my sister-in-law, her family owns a nursing home. So we put her there.
Sometimes
My sister, yeah, and my grandma's super, like, she was in a different nursing home before that, because for some reason they didn't have space in my family's nursing home, so they had to wait for space to happen, like, basically, like, in my person have to move, and then she takes that back.
Yeah, my grandparents took care of my great grandpa, but they got to they had issues themselves, and the last year they had to put them away.
She has, like, the BiPAP machine on her, the BiPAP machine is, like a respiratory machine.
Okay, helps her breathe.
That helps her breathe. But what happened to her was we didn't know CO2 was not being released from her lungs. You know, you breathe in, you're breathing in oxygen and all that, and like when you breathe out like the extra thing, her thing, and so she had 89% CO2, which that's what made her unresponsive. So they had to give her a bunch of antibiotics, they put a foaming on her to abilities to help her breathe. So all that stuff can come out through all that, but she's getting better.
I saw it on Facebook. Is that the one you posted?
No, not that video.
No, I don't know. I don't remember a video.
No, it was a picture, it was a picture.
It's an elderly.
Yeah, like my dad got there and she was like talking and stuff.
I really hope she gets better.
I hadn't heard of her say anything or like most of it was just her groaning like when you meet her. But my dad was asking her questions. She was see, like, but she wouldn't like actually have a conversation. She would just reply back.
So she doesn't have like any memory loss or anything. She just, because she's old, she needs to be watched and taken care of. Like,
Yeah.
Oh, no Alzheimer's?
No, she doesn't have any of that.
That's great.
She has, like, I remembers things from when she was in, like, her teenage years in the 20s, like.
My great grandpa had Alzheimer's since he was like 80 or 79,
My
and he died when he was
my
like 80.
grandma's mind is intact, like, before, so the whole reason why my grandma was put in nursing home was because she went through 2 pneumonias and a collapsed lung. but before she went to the pneumonias, my grandma could still shower by herself. She still cooked.
Oh, wow.
She still walked on her own. Huh? Nothing. She took one pill for allergy.
And you know that, and that's how it is, like people that were born and raised like in the islands. My great grandma was 105 and no problem. She completely remembers everything. She still cooks.
The thing with her is that my grandfather died a long time before I was born. When my dad was in his 20s, his dad passed away, and ever since that, like my grandma has never worked a day. Like she lived in New York, and that's when he passed away. My dad took over, and then from New York they lived in Miami, and ever since she was living, all she did was like cook, like help my mom cook, wash the dishes sometimes, and sit down and watch TV and read. That's what she did for like her whole entire life. She never worked, and she never did any like drugs. She never drank. She never did anything. And like she was perfect. And then since she was so old, the pneumonia set her back.
I have a grandma like that.
Yeah.
I don't, I just think it's very
You get that from probably not wiping yourself good, you not take a shower.
Pneumonia.
It's from being clothes.
Is it?
It's not only from, you can get it from like getting a cold, like if you don't take care of the respiratory part of the cold, you can get bronchitis, you can get pneumonia. And the pneumonia was so bad that one of her lungs collapsed, and that's when she got really weak. And ever since that, she got pneumonia again, and then she overcame that. And that picture that I posted, you know, the picture of her making, that was like, that was in the beginning of March? It was the beginning of March, and she was already starting to walk again and stuff like that, and then
All right.
nowhere she just...
So now that we know what concentrations are, how to describe them, now we are finally going to put that magic number on them. And you're finally going to know what 0.1 m sodium chloride meant. Okay? So we're going to put numbers with our concentrations. But there are a number of ways, like I said, that we can calculate this. We're going to do each of them, but one of them is by far the most important one. Okay? So the first one we'll talk about is percent by mass. Then we'll have percent by volume, mass per volume, parts per million, parts per billion, molarity, which is the big one. Molarity is the most important one. And then there's actually molality. There's molarity, and then there's molality. Okay. So the first one was percent by mass. This one's simple enough. Okay? Take the mass of your solute, divide by the total mass of your solution, times 100. So you're just saying, of my solution, what percent of it is my solute? And so if you have 100 grams of solution, and in that 100 grams of solution, you know that there are 30 grams of solute, what's the mass percent? 30. 30 divided by 100, 30 divided by 100 times 100 is 30%. If we're mixing the two, maybe we don't know the total mass of solution, but we know the mass of the solute and the mass of the solvent. Just add them together. Masses are additive. Take two things, mix them together, the total mass will be the mass of the two things added together. So here's an example. We need to find the percent by mass of acetic acid in our vinegar that contains 2.7 grams of acetic acid and 122.8 grams of water. So our equation was mass of solute divided by mass of solvent. Oops, sorry, not mass of solvent. Mass of solution times 100. So what is the mass of my solute? 2.70. What is the mass of my solution?
Gotta add it together.
Be careful, you gotta add it together. It's mass of solution, not mass of solvent. And so you need to take 2.7 plus 220
125.5.
122.8 equals 2.7 divided by 225.5. So we said
Where did you get 2.8 from?
2.7 plus 1.
oh. 125.5. Okay. So then is 2.7 times 125.5 times 100 is what percent? 2.15. Does that make sense to everybody? It's just sort of like our percent composition. A month or two ago, we said take the mass of the one element divided by the total mass of the compound times 100. Here we're going to take the mass of our solute divided by our total mass times 100 to get the percent of our solute. Here's another one. We have sodium chloride dissolved in water. It says we have 10 grams of sodium chloride dissolved in 50 grams of water. So what number goes on top? 10.0. What number goes on the bottom? 60. The total. 60.016 times 100. How many percent? 16.7%. These aren't difficult. Percent by volume, same thing. The volume of solute divided by total volume of the solution times 100. But this is actually easier because I can't make you add these two together. Masses are additive. 10 grams plus 50 grams is always going to be 60 grams. Volumes, though, are not additive. When you dissolve a liquid or a solid in a liquid, you can't just take the volumes and add them together. Usually, the volume of the solute goes down when it gets dissolved. So 10 milliliters plus 50 milliliters does not equal 60. And you can't predict what it is. And so I have to give you that total volume. Here's an example. We dissolve 205 milliliters of ethanol in sufficient water to give us a total volume of 235 milliliters. We need to find the percent by volume of ethanol. And so in this problem, we don't actually know how much water we added, right? We know the volume of ethanol we started with. We know the final volume at the end, but we don't know the amount of water we added. And that's okay, because we don't need to know. All we care about is the percent of ethanol. And so it's just going to be 205 milliliters divided by 235 milliliters times 100 is 87.2%. So if you remember on the last exam, the extra credit question was talking about the ethanol solution that I make in lab to sterilize things. I said I use 70% ethanol. That's what I'm doing here. This is not 70%, this is close. But when I make that in lab, I don't measure how much water I add. I take a 100 milliliter graduate cylinder, I add 70 milliliters of ethanol, and I add water until I hit the 100 milliliter mark. I never know how much water I add. It doesn't matter, as long as it's 70%. We can also mix the two. Okay? This is grams of solute in volume of solution. Okay? In some situations, this can actually be fairly useful. We use this a lot for drugs, good drugs, not bad drugs, good drugs in the lab. And so some drugs, the dosing is based off of concentration, molarity, which we'll talk about. Other drugs, it's based off of, say, grams per liter. And so my drug in the bottle will have a certain concentration measured in grams per liter. And I know that when I add it to my cells, I need to have I need to add enough to get a concentration in a lower grams per liter. But it's just as easy as the other two. You just mix the grams and the volume. So it's grams of solute divided by volume of solution. You can do liters, you can do milliliters. It doesn't really matter as long as you keep track of what you're doing. In this case, it's going to be milliliters. If you're using grams, it has to be milliliters. Okay? If you're going to use kilograms, then you can use liters. But we'll do grams and milliliters. This problem is a little bit different than the others. This one we're going to work backwards. So this says saline is 0.9% mass by volume of sodium chloride. So we know that 0.9% equals grams of sodium chloride divided by milliliters of solution times 100. So it says for every 100 milliliters of solution, how many grams of sodium chloride is present? You can possibly do this one in your head because they're fairly easy numbers. My suggestion is to do the math. If you do the math on this one, you do the same math on difficult numbers and you'll get your right answer. So what we need to do is just plug that 100 milliliters in. I'm just going to take that 100 milliliters, plug it into my milliliters of solution. So in this case, these hundreds cancel, right? And so it's going to be 0.9. If these numbers didn't match, say let's make this 110. Now the math isn't easy. Now we actually have to do the algebra. And so I would divide by 100, multiply by 110. And I would get my grams of sodium. You're just solving for the one variable. Is everybody comfortable solving for that one variable?
That's a 9, right? Before the N is here.
That's a G.
Oh.
Yeah, so that and that are different things, believe it or not. Okay, now we're on molarity. So molarity is that capital M that is on all of our bottles in the lab. Molarity is by far the most common unit of concentration for solutions you're going to run into pretty much anywhere. It's what's on our bottles, it's what's on all my stuff in the lab. If you go into a hospital or a pharmacy, a lot of things will probably be in molarity. So molarity is signaled by the capital M. The capital M is very important, we'll see why later. The capital M equals moles of solute divided by liters of solution. Okay? It's very similar to that mass per volume that we just did in terms of we have volume on the bottom and then a measurement of how much of our solute we have on top. But instead of grams, it's going to be moles. Because moles, you can compare between compounds. If you're mixing two solutions to react them, and you know 1 mole reacts with 1 mole. And so you mix equal amounts of solutions, and you're good to go. But if you know 1 mole reacts with 1 mole, and your solutions in grams per liter, you're going to have to calculate how many liters of each one you need to get equal numbers of moles. So in this case, you do all that work ahead of time. Your bottles sitting on the shelf are in moles per liter. This is an example. So it says we have 117 grams of potassium hydroxide dissolved in sufficient water to give a total volume of 2 liters. So again, we don't even know how much water we have. It doesn't matter. 117 grams of potassium hydroxide with a total volume of 2 liters. We're told that the molar mass of potassium hydroxide is 56.11. We have to find the molarity of this solution. So molarity is moles over liters. Molarity is not on your cheat sheet. I don't know why. I don't make the cheat sheet though. But this equation is not on your cheat sheet, and it is an equation you will need. So it's molarity equals moles over liters. You just have to remember it's solute in solution. But the way I remember it is moles over liters. So we need moles. We need liters. Liters are given to us, right? It's just 2.00. So I can put that on the bottom. Moles, though, are not directly given to us, but we can calculate it. We know we have 117 grams of KOH, and we know that 56.11 grams of KOH is 1 mole. And so how many moles of potassium hydroxide do we have? 2.09 moles. So I just put 2.09 moles liters, and so it's going to be 1.045. Correct? That's not the end. Okay. So this is molarity. There are examples on the homework, at least one. It's not difficult. Okay. So I don't think we need to do more examples because it doesn't get much more difficult than that. Okay. Yes, you may have to solve for one of the other variables, but you can do that. Right? Just solve for it. If you have to convert between grams and moles, that's something you've done a million times now. That is molarity. Make sure you are comfortable with molarity. If you're not comfortable with molarity, let me know. Because if you're not, it's going to be a problem on quizzes, exams, and the final, and in lab. Okay? So the reason we have to make sure that molarity uses a capital M is that molality uses a lowercase m. If I were making these units, I would not have made them so similar to each other. Okay? In name or in symbol. But they are, and so we need to deal with it. Molality, lowercase m, is moles of solute per kilogram of solvent. And so molarity was moles of solute per liter of solution. This is moles of solute per kilogram of solvent. And the reason molality exists is because if you change the temperature of a liquid, the volume does actually change a little bit. It's not something, it doesn't change enough that we can have a formula to calculate it, but it does change a little bit. And so if you have a solution, you've calculated the molarity. When you heat it up, that volume is going to change. But the amount of solute you've dissolved in there is not going to change. I mean, if you put 50 grams of salt in there, and you heat it up, it's still 50 grams of salt. So that's not going to change. That will, which means your molarity is dependent on temperature. Usually in lab, we're at room temperature. And so it doesn't matter. It's not changing. It was made at room temperature. It was calculated at room temperature. As long as you use it at room temperature, it's fine. Even in more extreme situations where you're freezing or near boiling, that volume is not going to change enough to really change this, and so nobody actually bothers with it. But if you're in a truly extreme situation where you're at very high temperature or really low temperature, then it can make a difference, and so you have to use molality. Because the moles isn't going to change. Your 50 grams of salt isn't going to change, so the number of moles isn't going to change, and the kilograms of water that you have is not going to change. Kilograms is a measure of mass. Mass doesn't change with temperature. So molality does not change with temperature like molarity does. But molarity is not practical. So we don't use it unless we absolutely have to. Imagine you're in a lab, okay? And I give you a solution. It's measured in molality. I tell you, pour out enough solution so that your solution contains 10 grams of solute. You can't necessarily do it. With molarity, you can, because you know how many liters you have to measure out in order to contain a certain number of moles of your solute, which is however many grams you need. But here, this is moles of solute per kilogram of solvent. But they're mixed together. So if you have a mixture, imagine you have salt water, and I tell you to weigh out 10 grams of water. How on earth are you going to do that? You can't. And so it takes some really fancy math and really working backwards and thinking outside the box in order to actually use this in the lab. Okay, so we will not. We'll be using molarity. Molality is important for a property we're going to talk about. It's in this lecture, it's at the end, called colligative properties. So we're going to talk about how molality affects things, but we're not really going to calculate it or anything. But this is an example of how you would calculate it. So it says we have 56.7 grams of potassium hydroxide dissolved in sufficient water to give a total mass of 245.8 grams. To begin with, we're given the molar mass of our potassium hydroxide, and we need to find the molality. So molality, lowercase m, was moles of solute per kilogram of solvent. Do we have moles of solute? No, but we can calculate it, right? So we know we have 56.7 grams of KOH and 56.11 grams is a mole. So what is it? Slightly more than one. 1.01 moles. So our molality, 1.01. Now we need kilograms of solvent. Do we know the kilograms of solvent? No. No? Can we find it?
Yes.
Yes. We know the mass of our potassium hydroxide, 56.7. We know the total mass, 245.8. And so the difference between them is how much water we added. So we have 245.8 minus 56.7 equals what? 189.1. Do I take that number and plug it in here?
No.
No, why not?
You have to take kilograms.
Kilograms. Has to be kilograms. And so divide that by 1,000, so 0.1891 kilograms And so our molality is equal to what? .34 lowercase m. With molarity, we read it as 5.34 molar. With molality, we say 5.34 molal. Molar is a lot easier to say than molal. Okay? But that would be 5.34 molal. That's the concentration of our solution. That is the last slide we're going to go over today. And so next week after the exam, we'll find there's two concepts left in this set of lecture. There's dilutions, and then there's colligative properties. I think the last two problems on this big cumulative homework you now have, there's one dilution problem, one colligative properties problem.